So if you're using intersection to solve something, intersection method is just graph one side of the equation, graph the other side of the equation separately, and see where the two lines cross. So in your calculator, for this equation you're going to want to graph 4 to the x as one equation and graph 7 as one equation. So go to y equals, first y1 can be 4 to the x, down arrow to go to the next, y2 can equal 7, graph that. Perfect. You can see the point where they intersect, so as long as you can see the intersection, now you can just do second, calc, and then you want intersect, so number 5. Enter, enter, enter. And your intersection to the nearest tenth is x is equal to 1.4. So we have x is equal to 1.4. Your graph is going to look something like this, probably better than mine because I'm not a great artist with these things. But you'll have a crossing at about 1.4. Go through the x or go through the y-axis at 1. So look, something similar to that. For zero method, now you're just going to rearrange the equation so that one side is 0. So if you subtract 7 from both sides of this equation, you'll get a 0 on one side. So 4 to the x minus 7 is equal to 0. So you're going to grab your calculator, graph 4 to the x minus 7. So 4 to the power of x minus 7, graph that, and see where this graph is equal to 0. Graph is equal to 0 right there. You can see the crossing point where it crosses the x-axis. So all you need to do is second calc 0, enter. Left bound, the cursor is already to the left of the 0, so press enter. Right bound, move the cursor with the arrows until it's to the right of the 0, enter. Guess, enter. And your answer again, same thing, 1.4. If you were to draw it, this time your graph is crossing the y-axis at x equals -6, and it'll cross the x-axis at 1.4-ish. So it looks something like that. Again, probably neater for your version. If we're solving it algebraically, so now we have 4 to the x equals 7. So if you want to solve for an exponent, the best idea would be to rewrite this as a log equation. So if you're rewriting the exponent equation as a log, first you need to get the exponent expression by itself. 4 to the x is already by itself in this case. Next, to convert it to a log, the base of your exponent gets moved over to the other side of the equation and becomes the base of the log. So you get x is equal to, your 4 moves over to the other side of the equation, becomes the base of the log. So log base 4 of 7. So if you're going to do this in your calculator, you'll have to do log of 7 divided by log of 4. So you'd have x is equal to log 7 divided by log 4. So in your calculator, log 7 divided by log 4, and gets you 1.4 again. So x is equal to 1.4 no matter which method you use.